Okay, hello everyone, thanks for coming. As with every presenter here, I tried to figure out something that would be interesting in 15 minutes and try to make some sense out of it. So thanks for the introduction, but we're not really about monitoring. So what Terracotta does is trying to provide a solution for JVM level clustering, or generally clustering of Java applications, right? So that's me. I'm a developer at Terracotta now for about a year. I started a Belgian consultancy company called Uwin. We still do stuff once in a while. I created a Rive project, which is an open source Java web framework that uses continuations. And then I did a whole bunch of other open source things over the years. I was one of the people that started Gen2 together with Daniel. I'm a Sun Java champion, and then I researched native Java continuations. If you want to know more about that, you can always talk to me. But today we're going to talk about terracotta. This is weird because you've got this ticking going all the time. You guys don't hear it, right? But this is like tick, 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 tick. At other conferences, you've got this huge screen where you got a minute counting down, and here it's like tick, 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 tick. Okay. So terracotta is an open source clustering solutions for Java, right? So we're really focused on the JVM. That's the important thing to remember when looking at these slides. So let's look at the overview. So today, when people want to cluster something, when they want to scale out, they've got several app servers, they've got several JVMs, they've got several web applications, they've got state inside those web applications, and then they start scratching their heads because one system isn't sufficient anymore, and oh my God, we need to scale out, what do we have to do? Usually, they resort to some custom development, or they use existing solutions that they also have to plug in through custom development, like JMS or grid-based solutions, or things that are quite invasive. You can't really take a Java application that has been written for a single machine and say, okay, let's take it to several machines and make sure that your state is correctly clustered across all those nodes. Well, we think that that should be possible. So what Terracotta does, instead of plugging in your app layer, we go one level down and we plug into the JVM. Okay? So we don't need a custom JVM. We support Sun's JVM, we support IBM's JVM, we're working on JRocket. And the real aim is to eliminate as much custom code as possible, right? So it's really aimed to be transparent, to be plug-in, with the least possible effort, okay? That's a very nice ideal. Of course, it's not always possible, but most applications, we succeed in doing that. Now, why is this possible? I've actually ripped out a slide too much. I'm going to explain it like that. So the JVM has got a contract about memory management, right? They've got the Java memory manager in Java, guarantees how multiple threads access any given data structure that is shared by those threads. So what does this consist of? For example, you've got monitor locks around, you start a lock around the data structure, and then you start a monitor on it, you end a monitor on it, and while that monitor is busy, no other thread can access the data structure. You've got synchronized statements in Java for that. You've got other coordination tools like wait and notify on threads. And with all those tools, Java on a single JVM allows people to share data across multiple threads, right? And this contract has been written down in a spec. So basically what we've done is taken that contract and scale out a thread to another machine and use the same kind of guarantees. So nothing changes, basically. You still use synchronized statements, you still use wait notify, but instead of having multiple threads in one VM on one machine, you can have multiple threads in multiple VMs on multiple machines by using the same contract. So first of all, it's declarative, so we generally don't require that you modify your code. Now, there are people that prefer to work with annotations instead of XML. They prefer to do declarations with annotations. It's still declarative, but we support annotations. One major other feature is to be able to cluster, we don't require your data structures to be serialized. Since we plug in inside the heap, inside Java memory model, we can actually detect each individual change, each byte that has been modified, and just marshal those across the wire, instead of requiring you from implementing a specific serialization protocol and a deserialization protocol. This has various advantages. One of the most important advantage, in my opinion, is maintenance-wise. You've got complex data structures, you don't have to make sure that the serialization is done correctly over time. And another advantage is that we can really optimize a lot, because if you've got a huge data structure with a big tree, lots of branches, and there is one modification that is being done somewhere very deep down in that structure, we don't require everything to be serialized and sent across. Just that one little piece of data structure that has been modified will be shared on another node. So the other side effect of that is that across the cluster, each instance maintains its identity. So instead of, when you've got a serialization model, like what most other clustering solutions do, is you serialize the data structure, it goes across the wire, you deserialize it, it becomes another object, and if you do, let's say you should never do it, but if you do it, an equal statement, it will never work, because it's on another node, it will be logically another instance of that object. With terracotta, it will work. So this means that you don't have to start working with surrogate keys like a string identifier that identifies a particular entity. No, you can just use object identity and use your collections to get a specific data structure, and use get, and it will go through the collection and get whatever result is appropriate, instead of having to use surrogate keys for that. Okay, so one of the other nice benefits is, because we have one centralized server that is able to work in a fine-grained fashion, we can optimize things a lot. We can batch things up, and we can also allow you to have a virtual heap that is larger than what a single JVM can hold. So you can actually create a heap that spans, I don't know how many gigabytes, 40, 50, 100 gigabytes, as long as you've got storage space on the server, on the terracotta server, okay? So let's see how this works in practice. So I've got a server, I've got an application server that starts up, I've got a JVM that has been augmented with the terracotta libraries. It is simply by registering a jar file in the boot class path, for people that know a little bit about this in Java. So it's not invasive at all. It works with your existing JVMs. So this app server starts up, you've got your web application that starts up with a data structure, and you've got a piece of that data structure that is actually shared. So you declared something to say, this particular part of the data structure is what I want to cluster across multiple machines. Because you set that up in a configuration file, the terracotta server will actually plug in there and see what the data is and pull it back to the terracotta server, okay? So it arrives there, it is in the terracotta server. Now I've got another application server that starts up, that has got an entirely different data structure at one location, but it starts using the application, and it hits at a certain point in time that particular shared data structure, which has also been augmented with terracotta's functionalities. And at that point in time, instead of creating a new object from scratch, it will actually go to the terracotta server and fetch that object and use data that was put in from the other application server and use it in the second one, okay? Now let's say they've got a third application server. Again, I've got a shared object, but instead of using an entire, the entire data structures, the whole data structures that are stored on the server, I can actually just use a little bit. Say, okay, I'm just interested in that part, and I'm not accessing anything else, so it will not fold it in. Once you start going down, traversing the data structure, it will lazily fold that in and make sure that it will be there whenever it's accessed, okay? And then, of course, we've got functionalities allow you to monitor all these things, but they're very specific to terracotta and to clustering. But it does have certain advantages, because one of the things that has to be done properly is that your application has to be thread safe. So you have to have synchronized statements across shared data structures. And a lot of times this is not the case. So we give you meaningful error messages when that happens, and you can actually improve your application just by running it through Terracotta. Well, I did with many applications that I wrote, because when you write it on a single node, it's always wrong. This is a quick example. Typical hello world. So what does this do? I've got a list that contains dates. I create a new date, I add it to the list, and then I print out everything that's inside the list. And that's what this application does. Now, if I run this application by itself, there will always just be one entry in the list, and it will also always just print out that one entry. Now, with Terracotta, I can point to that dates data structure by creating a configuration file. So I'm saying the Hello World class has a dates data structure. I want to lock automatically on it so that each synchronized statement becomes clustered. And when I do that, I can start the Terracotta server, I can start the client as many times as I want. The first time it will get an output of a single line, the second time I get 2 lines, and so on. Why? Because that dates data structure is stored in the server, and each time that I start a client will actually be folded in, and this list will grow bigger and bigger and bigger. Okay? Now let's look at another very simple example about coordination. Let's say that this application, I only wanted to start adding information to that list when all the nodes are at a certain point. So I can use JDK's 1.5 cyclic barrier for that. I can say, okay, I've got a barrier, and I want to wait until all the nodes have joined that point. So I create, again, a field in that class that I call barrier. I add it as a root to the Terracotta's configuration file. And then when I start the server and I start a client, so you notice here that I added a JVM property called nodes. So this has to be correct, of course. It has to be the same number of nodes as the clients that I'm starting. It will just, let's say that I start 2 clients. It will hang until those 2 clients have joined, and only then it will execute the rest of the program. And this works in a clustered fashion across multiple nodes. So let's wrap up. Basically, Terracotta works under the cover. It follows the Java memory model to guarantee correctness. So this is not crazy voodoo magic that you don't understand. It's been widely documented, and it's been out there for several years. We just implemented another version of the Java memory model that works across multiple nodes. Another thing to remember is that you will not code for it, you architect for it. You think about data structures and how they will migrate across your nodes. You don't get a clustered hash map that you will put your stuff in and then get it back from the other side. You can, if you want to. You can just create a hash map, make it a root, and then it becomes a shared data structure, and then you get a clustered hash map. So you have to think a little bit differently. You don't get an API that you can code against. It really has to be identify which parts of your data structures have to become shared, and those will become declared inside Terracotta's configuration file. Okay, so that's about it. So no serialization, fine-grained field level changes. It allows you to traverse your object graphs in little parts. Things can be folded in lazily, only when you access it. The JVM's coordination is maintained across the cluster, and you can have a large virtual heap. And now we're also working for the next version on a clustered wild statistics monitoring tool that allows you to gather data while your system is running and then analyze it in real time or afterwards to see how your shared data is actually behaving and how it impacts any kind of system behavior. So this is a little bit what Zabbix also does, but for individual operating systems, and Hyperic does that also. And we try to drill down really into the data structures. That's for the next release. Thanks for coming. So if you've got any additional questions, you can always email me. I'm not sure that we still have time. We still have 1 minute. I put some papers here that you can take away. It's got this, but much better detailed and explained with source code, and then my business cards if you want to email me. You have a question, sir?
Yeah, I'd like to know if there is any way with Terracotta to achieve high availability.
Okay, the question is, can you achieve high availability with Terracotta? Of course. That's one of the main reasons to use Terracotta. So what basically the architecture is, you've got a Terracotta server, you can set up several other Terracotta servers that are passive servers, and that start up in hundreds of milliseconds. So they can take over easily, and then you have your nodes that connect to the Terracotta server. If any one of your client nodes goes down, you can start up another client node, and it will take off where you were before. I don't think we've got time. We can do it in private. Thanks a lot.